Okay, so simplify. So I'm going to use my order of operations. You do have to show your work. There are a couple people that I gave F's to on their homework because they didn't show their work. So just FYI, that will happen. All right, so the first one, order of operations. Please excuse my dear Aunt Sally. Looking for parentheses first, don't see any. Looking for exponents, don't see any. Looking for multiplication and division, yes. So 7 times 2 is what I'm going to start with. Okay, so 7 times 2, that's 14, and then I can add 4 plus 14 is 18.
Easy.
All right, the second one, exponent, parenthesis first. What's negative 3 squared?
Negative 27.
Positive 9. Okay? Negative 3 squared is negative 3 times negative 3, which is positive 9. And then after that, I look for multiplication and division. So 5 times 2, that's 10. So that's 9 plus 10 minus 4. And then I add and subtract from left to right. So 9 plus 10, that's 19. And 19 minus 4, that's 15.
What? So wait, how'd you do the negative? Dude, I got negative 21. Wait, I got negative 27 for the negative 3 squared.
But I know, but negative 3 squared is times itself. So it's negative 3 times negative 3, which is positive 9.
I guess so, if you say so. Wait, well, I got negative 27. I did it cubed. Oh.
Yeah, you did cube, not squared.
Oh,
All right, the third one. Start off with your parentheses. So do what's inside first. So 7 minus 3, that's 4. And then I'll rewrite everything else. And then after that, I will do exponents. So I'm going to do the 4 squared and the 3 squared. So 4 squared is 16. And 3 squared is 9. And then here's where Simon was asking. I now do my multiplication division from left to right. So I do have division and I do have multiplication. But I do it from whatever comes first to last. So 18 divided by 9 is 2. I did that part. And then 2 times 9, that's 18. And then 16 plus 18 is 34.
Showing your work, like, is this showing your work?
Oh, yeah, that's fine.
Like, I did it all on one iPhone.
All right, homework questions from that worksheet. Anybody have any questions?
Oh, the homework.
Yeah, which one? Yeah. All right, 23 said, evaluate each expression for x equals 2 and y equals 5. And they gave us x plus 2 divided by 5y squared squared. All right, so I'm going to plug in the numbers where they go. So my x is 2, so that'll be 2 plus 2 on the top. On the bottom, that's 5 times y squared. So that's 5 times 5 squared squared. Okay? Then remember we talked about it. Finish out the top. So 2 plus 2, that's 4. And then start working on the bottom here. I do exponents first before I multiply. So 5 squared is 25. And then 5 times 25 is 125. And then I will square the whole thing. So 4 squared is 16. 125 squared, I don't know. 15,625. And you can leave it like that. It doesn't reduce. If you made it a decimal, I'll live. But that's 23. So if you missed it, fix it.
I got a 0.000.
That's the same thing.
0.096. Really?
Yeah.
I got it.
But we didn't have to, like...
I did it.
Anybody else?
Is they talking?
All right.
This is
All right, double check for your name.
way out.
Double check for your name, then pass it up.
My name.
Yeah, that's the right one.
Oh, I got
Ricky Bob. That's it. Yep. All right, guys. Today we're gonna focus on real numbers and the number line. mostly square roots today and the real number system. Alright? Alright, so the first thing that we're going to talk about is square roots. Okay, a square root is the opposite of squaring. I'm going to move this up. Square root is the opposite of squaring. So, for example, if you know that the square root of 49 is 7, then 7 squared is 49. If you know that 10 squared is 100, then what's the square root of 100? 10. If you know that 7 squared is 49, oh, I just did that one. If you know that 8 squared is 64, what's the square root of 64? 8, and so on. That's that relationship between squaring and square rooting. They're opposites. They undo each other, just like addition and subtraction. A couple words that you might see in your book is radical symbol. Radical symbol is just that square root symbol. Radical symbol is something that talks about all square roots, cube roots, fourth roots. That's a radical symbol. In Algebra 1, we only focus on square roots, but Algebra 2, we focus on cube roots, fourth roots, and fifth roots. You will also see the word radicand. Radicand is the number that's under that root. So if I said, hey, what's the radicand of this? We would say 49 because it's the number that's under the root. All right, so I'll give everybody a chance to keep going. If you want to write that down, you don't have to write down everything. Where's your bell work paper?
My what?
The work that you use for bell work. Paper.
The neat one?
Yeah.
Wait a minute, was you supposed to keep those?
Yeah, because that's where you put your notes.
He turned it into homework.
No, I didn't turn it into homework. I got them right here, I think. Yeah.
All right, well, put your notes on that.
Somewhere. I think so.
Here, just use this because I'm going to wait. All right, so the directions just say, what is the simplified form of each expression? So we talked the past couple days about simplified. Simplified is when you evaluate. You figure out what it's equal to. You make it in simplest form. These you don't have to show anywhere. All right, so the square root of 81. What is the square root of 81? 9. All right, I want everybody to use their calculator right now to find the square root of 81 just so that you know how to type it in. If you need help figuring out how to use your calculator for square roots, raise your hand and I'll come help you. You need help?
No. Oh.
Alright. Anybody else need help with their calculator? Oh, sorry.
I'm not good at it.
On yours, Alright, so the next one, remember how we talked about last week that if the problem's a fraction, the answer should be a fraction. So the square root of 9/16. There's a trick to these that you don't even have to use the calculator. If it's a fraction and it's a square root, you just square root the numerator and square root the denominator. So what's the square root of 9? 3. And what's the square root of 16? 4. So it's 3/4. It's quick like that. Okay, cool. All right, you all try these two. All right, so what's the square root of 64? 8. And the square root of 136? 1/6, because square root of 1 is 1. Square root of 36 is 6. All right, now we're going to talk about what happens if the number under the root cannot be square rooted. Let's say that you have like the square root of 65. That's a decimal. Right now, we're not going to deal with decimals. We're going to do something called estimating. So the square root of an integer is called a perfect square. So these numbers under here are perfect squares. You will look up here. Turn you with me here. Perfect squares are numbers that have been squared. Okay? So all these numbers in these boxes are perfect squares. Because 2 squared is 4. 4 is a perfect square because it was 2 squared. 25 is a perfect square because 5 squared is 25. 256 is a perfect square because 16 times 16 is 256. Do you all understand that? Yeah. That those are numbers that have been squared. That's what makes them a perfect square. Now, like I said, if the radicand, the number under the root, is not a perfect square, we're going to estimate. And this is something I would write down. To estimate, we are going to find the next closest perfect square and use that to help us simplify. And these are not going to be an exact amount. These are going to be an estimate because that radicand, that number under the root, is not going to be a perfect square. So like I said, they're going to give us a problem, and we're going to look to find which perfect square it's closest to. All right, so here's the first one. The directions do say the word estimate. We are not doing decimals. We are estimating. Therefore, we're giving an estimate amount, not an exact decimal amount. Okay? All right, so the square root of 386. Let's go over here to our perfect squares. Which perfect square is 386 closest to?
20.
We're going to say 400. It's closest to 400 because 400 is a perfect square. It comes between 361 and 400, right? Is where the 386 falls. But 386 is only 14 away from 400, and 386 is 24 away from 361, so it's closer to 400. Does everybody agree? Yeah. The square root of 400 is what, Cannon? 20. What you said, 20. So I can estimate that the square root of 386 is about 20. And that would be it. Those squiggly equal sign means it's about. It's an estimate. It's an approximation. A regular equal sign means it's exactly that amount. But a squiggly equal sign is an approximation. All right, the square root of 24. So let's all look at our perfect squares over here. 24 is closest to which perfect square?
5.
No, we're going to say 25. It's closest to 25. And what is the square root of 25?
5.
5. So we can say that the square root of 24 is about 5. Okay. All right, it says to estimate the square root of 289. And this one's kind of a trick question. 289 is a perfect square. So square root of 289 is 17, so I can say that this one is actually equal to 17 because that's exactly what it is. I don't have to approximate that one. All right, so I'm going to give you all 2 to try alone. I don't know why I put the equal sign in there. That's fine. 34. It was closest to what perfect square?
6.
36, so we're going to estimate this to be about 6. What about the square root of 110? It was closest to 100, which we would estimate to be about 10. And the reason that this one's 100 instead of 121 is because it's 10 away from 100 and it's 11 away from 121. I tried to trick you all a bit there.
Nope.
All right, so the last thing that we're going to get to today is the real number system. It's 5 definitions. I don't want you to write down the whole definition. I'm going to underline the part that's most important for us, okay? All right, so the real number system is important because it's something that you all should have talked about last year. This year, I did it with Algebra 2 yesterday. Geometry did it this week. Pre-Cal does it right off the bat. It's super important because when you get to Algebra 2, you're going to focus on the imaginary number system. And you have to know the real number system to be able to do that. All right? I know. The imaginary number system. The imaginary number system is all about the square root of -1. Yeah, but you don't need to worry about it yet. All right, so the first important part of the real number system is the rational numbers. And it's any number that can be written as fractions. So that's the important part. The rational numbers is any number that can be written as a fraction. And when we see those, we're going to think of numbers like 3, or -2, or 1 1/2, or 0.25, or -1.7 repeated. Those are all numbers that can be written as a fraction. So basically the rational number is any number that you are used to using, okay? Now, in the rational numbers, there are 3 subsets. We're going to start with the hardest, most exclusive subset to get into, all right? And that is the natural numbers. The natural numbers are positive counting numbers, not including 0. So that would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. Okay, so it's going to be, the natural numbers are counting positive numbers, not including 0. Does anybody know why we may not include 0 as a natural number? It's not natural because it's not,
It's in the in-between.
Well, yes, and that's because it's not, it's not an amount, and there's 2 other things. It's nothing.
0.
It's neither positive nor negative, and it's neither even or odd. That's why it's not a natural number.
Well, 0 seems like even.
It's
If you
not,
really
though.
think about
It's
it,
nothing.
0 is nothing.
Right.
And that's even.
The second set of numbers that it's hard to get into are the whole numbers. And there is only one difference between the whole numbers and natural numbers. The whole numbers are counting positive numbers, but it includes 0. That's the only difference between the 2. They're both positive counting numbers. Natural does not include 0, but whole does. So 0, 1, 2, 3, and so on. And these are words that you're going to have to know for your test. So I'd be writing them down, okay? You're going to have to know them. You will not get a word bank. You just have to know them and their definitions because you're going to have to name numbers based upon them. All right, and then there is the integers. The integers are positive and negative counting numbers, including 0. So like -3, -2, -1, 0, 1, 2, 3, and so on. All the positive and negative counting numbers. We just got one more. You're live, Steve. just got to do one more. So if you're not rational, then you're irrational. And that's what's going to be last, okay? Irrational numbers are numbers that cannot be made into a fraction. And there are only two that you're going to know so far in your math career, okay? Those are the only two we're going to write down. So irrational numbers are going to be square roots of non-perfect squares and pi. So those are the only two that you need to write down. Square roots of non-perfect squares and pi. So like the square root of 110 would be irrational because square root of 110 is not a perfect square. Or like the square root of 15 would be irrational because we don't know what the square root of 15 is and pi. If you ever look at pi on your calculator as a decimal, you will notice that there is no type of repetition in that decimal. There's nothing repeating, okay? So that's what makes it irrational. There's no way that that could be written as a fraction if there's no like pattern to that decimal. Same thing with square root of 10 or square root of 15. If you did that on your calculator, you'll notice there's no repetition in that decimal, therefore it can never be written as a fraction. There's no pattern. All right, so they're going to give us a number, and we're going to have to name where it belongs. Now, there's a picture in your book and this picture that I drew on the board that are pretty similar. This will help you do these a lot quicker, okay? So the smallest group that it's hardest to get into is the natural number system, all right? And the natural number system are positive counting numbers, not including 0. So if you fall there, you're automatically a whole number, an integer, and a rational. You see how that works? If you're in this small subset, then you're automatically part of all this. If you're a whole number, then you're automatically an integer and a rational, but you're not natural. If you're an integer, then you're automatically a rational. All right, because these are positive counting numbers, not including 0. If you were a negative counting number, you would fall into the integers and rational. Okay, and we're going to talk about that. You'll see once we get into these. So we're going to read the directions first. To which subset of numbers does each number belong? So when it says subsets, it's talking about these words that we just learned. All right, so the first one is 15. And here's what you're going to ask yourself. Is 15 a positive counting number? Yes, you can count to 15. Therefore, I asked myself, okay, is it natural? Is it a positive counting number not including 0? Yes. So it's natural. Then I'm going to ask myself the next one. Is it a whole number, a positive counting number including 0? Yes. Is it an integer? Is it a positive or negative counting number? Yes. And is it rational? Could I make that into a fraction if I wanted to? Yes, because you know how you make a whole number a fraction? Put it over 1. All right, so it is that. So that's what I'm talking about. If you're natural, then you're automatically whole, integer, rational. If you're a whole number, you're automatically an integer and a rational. If you're an integer, you're automatically rational. But if you're rational or any of these other ones, there's no way that you could be irrational. If you're in this side, you're in this side. That side you cannot be in. You can only be in one of them. All right, let's look at this number. Negative 1.4583. All right, here's what you need to ask yourself. Is that a number that you would count by? You would typically count, okay, negative 1.4583. So the next one would be negative 2.9, blah, blah, blah. Would you count by that number? No. So if that's not a counting number, that knocks out natural, whole, and integer, because those are all positive and negative counting numbers, right? So I've got to decide, is this rational or is it irrational? It's rational. And the only reason that it's rational is because there's only two things that are irrational. Square roots of non-perfect squares. Is this a non-perfect square root? No. Is this pi? No. So that means it has to be rational. All right, square root of 57. Quick, tell me, what's the square root of 57 without your calculator? Do you know? I don't know the square root of 57. 57 is a non-perfect square. So this is a square root of a non-perfect square, which makes it irrational. All right, negative square root of 36. Quick, what's the square root of 36? So instead of thinking of this as negative square root of 36, I'm going to think of it as negative 6. Because I know the square root of 36 is 6, right?
Yep.
All right, so here's my question. Is this a positive counting number?
No.
Which means that knocks out natural and whole, right? Because natural and whole are both positive counting numbers. One includes 0, one does not. Is it an integer? Is it a positive or negative counting number?
Yes.
Yes, so it's an integer, and if you're an integer, you're automatically what? A rational. Not irrational, a rational. Because I could make that into a fraction if I wanted to. All right, you all tried this one. So the square root of 9. So quick, think. Do you know the square root of 9? Do it in your head. Ethan, you gotta pick up your pencil to do it. Oh, dang it. That's good. All right, quick, what's the square root of 9? 3. So I'm going to think of this as 3. Is 3 a natural number? Is it a positive counting number, not including 0?
Yes.
Yes. And if you're natural, then you can automatically assume your whole integer rational. If you don't understand that yet, then you need to think, okay, whole numbers, is it a positive counting number, not including 0, or including 0? Yes. Okay. Is it an integer? Is it a positive or negative counting number? Yes. And is it rational? Could I make that into a fraction? Yes. All right, you all try these two. Oh, there's 3 right there. I'm going to cover up. So try those two. And that's number 2 is just 3/10, not 2.310. It's just number 2. I'll call you Slumberella. Mr. Sissel. Uh-oh, thinking with your eyes closed. All right, 3/10. Is that a counting number? Would you typically count by 3/10?
No.
No, so I would knock out natural, whole, and integer, because natural, whole, and integer are all about counting numbers. 3/10 is not a number you would count by. Is it rational or irrational? It's rational because it's a fraction, and rational numbers are any number that could be made into a fraction. All right, what about negative 0.45?
Rational.
It's just rational. Negative 0.45 is not a number I would typically count by. All right, so that knocks out all 3 of these. So it's either rational or irrational, and it's rational because I could make that into a fraction if I wanted to. Does anybody know how you would make a decimal into a fraction? Without a calculator?
No.
What decimal place does this go to? What decimal place is this? This is the tens, hundreds, so you put 45 over 100 and reduce it. That's how you get a fraction from a decimal. All right. You didn't know that? I got all kinds of math tricks. Got my sleeves. All right, what's this one?
Irrational.
Irrational, because what is a square root of 12? Do you know?
Nope.
No. And if you take the square root of 12 on your calculator, it's a decimal. All right, so this is the square root of a non-perfect square, which makes it irrational. All right, so the practice of these are going to come from you actually using the little chart. Maybe you write that down or find it in your book if you didn't. That'll help a lot. Real quick, before I give you the homework. Which number is bigger?
4.
And how could you show that in a math way that that number is bigger?
Number line?
A number.
Greater than or less than. And the greater than or less than symbol always eats the bigger number. So I would do something like that, right? All right, which number is bigger? The square root of 15 is bigger. And there's two ways that you can figure that out. You could use your calculator to figure out what the square root of 15 is. Or the square root of 15 is close to
4.
16, which is about 4, so that's how I know it's bigger. All right, what about... Which one's bigger? Negative 3 2/5 is bigger than negative 5, because remember, if the numbers are both negative, the one that actually looks smaller is bigger, right? Okay. All right, so there's your homework for tonight. 10 through 22 even, and 28 through 36 even.
That ain't that much.
Yeah, go. About 5 minutes.
I'm not starting it.